in that analysis of perfect frames. Okay, analysis of perfect frames. Uh, Frame, the word frame comes from, truss. Okay, so where we will use these trusses? So trusses we will use, at the portico or in front of your home or in front of your houses or for construction of huge buildings. Means for example, construction of huge shopping malls where you require to use less number of columns. Okay, so if you are required to use less number of columns means the load which are going to come from the frame should be very less. Okay, so for example, if you take cinema theaters, so which were built using frames only, and if you take DMart, something else, shopping malls which were built with the frames only. So there, the area utilization should be maximum. That means we should reduce less number of columns. Okay, so we should put there a less number of columns. So if you are going to put less number of columns, the load which is going to come onto the remaining column should be very less. So that's why we will go for like less self-weight members, which will give less load onto the columns which we placed already in the area, right? So perfect frame. Okay. So for perfect frames only we can solve. So if you have perfect frame, then what is imperfect frame, right? So first I will start with the frame. Okay, so frame, basically we have frames two types, right? So one is perfect frame, another one is imperfect frame. Okay, so we have the equilibrium equation in the frames, like n is equal to 2j minus 3. N is equal to 2j minus 3, where n is number of members number of members, and j is number of joints number of joints. Okay, so if a particular frame satisfies this equation, n is equal to 2j minus 3, that means number of members should be equal to 2 times of number of joints which were there in the frame minus 3 minus 3, right? So if it satisfies the equation, then we will call that frame as a perfect frame. Then we will call that frame as a perfect frame. So if n is not equal to 2j minus 3, if n is not equal to 2j minus 3, then we will call that as a imperfect frame. Okay, so perfect frame, very very important. So I will show you old question paper, short answers. You will get short answers 5 marks in this only. What is perfect frame, what is imperfect frame? Okay, so frames are two types, perfect frames and imperfect frames. Okay, so if the equilibrium equation n is equal to 2j minus satisfies a particular frame, then we will call that frame as a perfect frame. Okay, where n is number of members in that frame, and j is the number of joints in that particular frame. And if n is not equal to 2j minus 3, n is not equal to 2j minus 3, then we will call that frame as a imperfect frame. We'll call that as a imperfect frame. So as you know, if n is not equal to 2j minus 3, right? So if n is not equal to 2j minus means, not equal to means either n should be less than 2j minus 3, or n is greater than 2j minus 3, right? So n is less than 2j minus 3, or n should be more than 2j minus 3. So if n is less than 2j minus 3, n is less than 2j minus 3, then we will call this frame as a deficient frame. Deficient. Okay. So deficiency is there. Number of members are deficient than the number of joints. So this frame is called deficient frame. So if number of members are more than 2j minus 3, we will call this frame as a redundant frame. Redundant frame. Okay, is it clear? So basically, frames frames are two types. One is perfect frame, another one is imperfect frame. Perfect frame and imperfect frame. So what is perfect frame? Perfect frame means when a frame satisfies the equilibrium equation n is equal to 2j minus 3, then we will call that frame as a perfect frame. So when a frame not satisfies the equation 2j minus 3, n is equal to 2j minus 3, then we will call that frame as a imperfect frame. So if it is not equal to means it should be less than 2j minus 3 or more than 2j minus 3. So if it is less than 2j minus 3, we'll call that frame as a deficient frame, and we'll call that if n is greater than 2j minus 3, we'll call that frame as a redundant frame. Redundant frame. Clear? Redundant frame. Okay. Now in the frames, in the frames, in the frames, again we have two types. In the frames again we have two types. Pin jointed frames. Pin jointed. Pin jointed frames. Okay. And rigid frames. Rigid frames. Pin jointed frames and rigid frames. Okay, so actually, what is a frame? What is a frame? So frame is nothing but a structural member. Frame is nothing but a structural member which is consisting of, it's a structure which consists of members, which consists of a members that we will call as a frame, right? So again, frames depends upon the connections, depends upon the connections, right? So if you may connect, say for example, I have a frame like this, I have a frame like this. Okay, so this I could call this as a joint, and this as a joint, and this as a joint, right? So I can connect, so this is member, I will call this as a member. Okay, so we can call this as a member, and this is member, and this is member, and this is a joint, this is a joint, and this is a joint. I could connect this joint with the help of welding. Okay, so that means you can make this joint as a permanent, you can make this joint as a permanent, or you can make that joint as a temporary, you can make that joint as a temporary. You can make this joint as a temporary, right? Permanent and temporary. So if this should be permanent, then you can join these two members, you can join these two members using welding, and you can join these two members using pins. That means you can use rivets to join these members, or you can use bolts to join these members. So if the members in the frame are connected with rivets or bolts, then we will call that frame as a pin jointed frame. Pin jointed frame. So if these joints are connected with, say, for example, welding, or a frame which is made with, say, cement concrete. If it would be cement concrete, obviously you know that the cement concrete frame should be rigid only. Okay, it should be rigid only. And or else if you are using, say, mild steel members to made a frame, then if you connect these joints with the welding, Okay, if you connect these joints with welding, that means if you make this as a permanent, we'll call that as a rigid frames. We'll call that as a rigid frames. Then why I emphasize on these two means, we have in this frames, we have the solution for pin jointed only, because pin jointed frames are determinants, determinate frames. These are determinate frames, and rigid frames are indeterminate frames. Indeterminate frames. So, friends, let me explain what's the difference between determinate and indeterminate. Okay, so as you know, we have three equilibrium equations, like sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. So these three are the equilibrium equations. What is sigma h is equal to 0? Sum of horizontal forces must be equal to 0. Similarly, sum of vertical forces must be equal to 0. Similarly, sum of moments must be equal to 0. So we have to solve any kind of structure, we have these three equilibrium equations. So using these three equilibrium equation, you can able to find out. Okay, we can able to find out only three unknowns. Only three unknowns. If a structure, or if a structure or if a frame which is having more than three unknowns, these three equilibrium equations are not sufficient to solve that frame or structure. So we'll call that structure as a indeterminate structure. We will call that structure as a indeterminate structure. So we have another methods. We have another methods to solve indeterminate structure. Like slope deflection method,
Sir, your voice is not clear, sir. Sir, still it is not clear, sir. Still it is not clear.
yeah, sorry, now
Okay, sir.
clear.
Okay, sir.
Yeah, okay. So uh, if it is if these three equations are not sufficient to solve any structure, we'll call that as the indeterminate structure. So to solve the indeterminate structure, we have different methods how to solve the indeterminate structure. So using those methods, we can solve the indeterminate structures. Now coming to the determinate structure. So determinate structure means we should talk about only pin jointed frames only. So in this chapter we can solve perfect frames perfect frames which